This video is an introduction to functions where we're going to look at the main properties of the four main graphs. Now, I want us just to look at an overview of all the videos that are following up on this. Now, here we have the properties of the graph. That's what we're going to do now. And then you'll see that grade 11 is represented by the blue, and then grade 12 is represented by the purple. So in grade 11, you learned all of these, and grade 12, you will or are, whether you're in grade 11 or 12 right now, going to learn these. Now, in the end of your matric year, you are going to be tested, or you are going to, in your final exam, write of all of this. Okay, so I'm going to try and give you all your questions that you are going to be expecting, or the main questions, level 1 to 3 questions that you can expect for the final exams in the functions videos that we are going to look at. Now, these typical questions are like finding the equation of given graphs, finding intercepts, turning points of parabola, sketching the graph of a given equation, domain and range, axis of symmetry, asymptotes, continuity, increasing and decreasing, average, gradient, reflection and translation. Then the graphical interpretation, where you're going to find the length and then the maximum distance, and then things like for the value of x, for which fx is, for example, greater than x, or equal to another function, or greater than another function, or when you multiply two functions together, where is it less than 0, and then also nature of roots. And then going on to grade 12, vertical and horizontal line test, that's just something simple. And then inverses, it forms a big thing in where you do the logarithmic function and so on. Sketching the graphs, finding equations, domain and range, and restrictions. Okay, so let's look at the four main functions that we work with. So we have the straight line, we have the parabola, the hyperbola, and the exponential function. So I think it is quite important to know the basic shapes and also the equations, standard equations of each of these. So the straight line, we've got obviously a straight line, and we've been doing this since grade 9. It's got the m value and a c. So the equation is y equals to mx or fx. So fx and y is basically the same thing. Okay, we just notate it as fx to say it is a function in terms of x. Mx plus c, and then we have the let me just continue on this. The m and the c are the variables that change the function. So this is going to be real values, and determining on what those values are, that's going to determine what this function will look like. Okay, and then we have the parabola. So the parabola comes in one of two, actually three, but these are the most common two standard equation. Well, this is your standard form, and then we can put it in the completed square form. We can also factorize it, which we will see later. But these are the most common two that we use. So we've got variables a, b, and c that are replaced by values, and then in the completed square form we've got a, p, and q that represent values. For the hyperbola looks as follows, and the standard form is f of x equals to a over x minus b plus q. And then finally we have the exponential, and the exponential is f of x equals to b times a. These sometimes can be a k, or it's not really that fixed as the b and q, but then b times a to the power of x minus b plus q. Okay, so what we're going to do now is going to look at each of these individual functions and see what role does the variables play. How does that change the function? And then just also some basic important things regarding the functions. So obviously we're going to start with the straight line. So we have f of x equals to mx plus c. So if we start with the gradient is basically the slope of the line. So it could be this line. If I do this, the line's slope can change. Okay, so it can be negative or it can be positive. If it is positive, it slopes to the right. If it is negative, it slopes to the left. Okay, and the gradient actually has a formula to find it, and we can only find the gradient if we know 2 points on the line. So if I have like these 2 points, and let's say I've got this coordinate, let's say x1, y1, and then another coordinate x2, y2, then I can substitute these coordinates into this formula, and we can find the actual value of the gradient. All right. And then, like I said earlier, if the gradient is positive, it slopes to the right. If the gradient comes out a negative number, then the line will be sloping to the left. Okay. Then we can move on to the y-intercept. Now, what the y-intercept does is it shows you where the graph cuts the y-axis. Okay. So let's say maybe this is going through -1. Then that means your c value will actually be -1 wherever the line cuts. So the c value, the y-intercept or the c value can actually move the graph down, or it can move it up. So let's say it's moved down, then it could maybe lie at -3. Or if we basically move it up, it can basically be 1. So that's basically your c value. Okay, now moving on. The next one is the parabola. So the parabola, we've got our standard form, ax squared plus bx plus c. And then we can change it, or we can rewrite it in its standard or completed square form. So to do that, it's part of algebra actually as well. And if you want to recap on how to do completing the square, you can always go to the video R2204 in the algebra section. Okay, and then next we can also do it in its, or we can write it in its factored form, and that you also learned in algebra how to do factorization, and more specifically how to do quadratic factorization. So that is in the video R2201. Right, so how do these affect the graph? Now, the a value in all three of these functions do the same thing. They have the same purpose. And when the a value is positive, the graph is smiling. When the a value is negative, the graph is crying, basically, if you want to remember it like that. Then the b doesn't have really, we can't really say much about the function from the b value. That is why we tend to want to kind of do this, so that we can have more information about what the graph looks like or where it lies. Now, next we've got the c value, and as the straight line as well, this c value does the same. It shows you where the y-intercept is. Okay, so that's the c value. The c value, if you add a constant basically to your graph, it basically shifts the graph up and down, and then it changes the c value, which basically just change where the graph cuts the y-intercept. Okay, now moving on to this form. So before we go into detail about p and q, I want us to start with a very basic function. Let's say we've got a function over there. Its turning point lies on the origin, okay? And the origin is 0 and 0, okay? And this function, if the value of a is 1, then this function is y equals to x squared. Very basic, the very basic function. And that means it hasn't been moved left or right. So once we do that in grade 10, we learned that the function can actually move up or down, okay? So let's say the function moves up. We can maybe make it 5 units. If the function moves up with 5 units, the equation will change. So now it goes through 5. The equation will change to y equals to x squared plus 5, okay? And that 5 over there, that is the q value, all right? And we can see then the turning point changes to 0 and 5. Okay, so that is now the new turning point, and that is what the function looks like now. Then in grade 11, we start moving our functions left and right as well. So if we basically take this function, let's move it all the way here, and it lies there now. Then this is where the p-value comes in. So now the turning point, let's say it's to 7. Let's say we moved it to 7, then we have like 7 and 5. Okay, and what do our equation or our functions look like? Would be y equal to x minus 7 squared plus 5. Okay, now very important. what happens now is you can see when we move the function up, it just simply became +5, because if you go up it's plus, if you go down it's negative. But not so with the p-value. In our standard equation you can see there's a negative there. Okay, so if I'm going to make my p-value a 7, right, it's obviously a positive value. Okay, so the function is going to move to the right. But we have this irritating negative here in the standard form, so that when we substitute our 7 into this equation, it looks like a -7. Okay, so that's something you have to, for all the functions basically, to remember that when you move the function left or right, if you have it in the equation, if the equation shows that it's x minus 7, it actually means that it was moved to the right. And similarly, let's say we moved it to -7, then it would be y equals to x minus -7 inside squared plus 5. Then what happens here is this negative and negative becomes a positive. So this function would look like it a positive inside, but it's actually that your p-value is a negative, but it became a positive because it's two negatives become a positive. So that's something you have to keep in mind. When you move it up or down, the q value is just the value. It goes up, it's positive. It goes down, it's negative. But when you move a function left and right, especially when we're going to move to the hyperbola as well, it happens with the hyperbola, it happens with the exponential. It's actually going in the opposite direction that it looks like. Okay. Now, just to end off, so what does the p and q values do? They tell us where the turning point is. Okay, so this is going to be the p value, and this is going to be the q value for the coordinates of the turning point. Okay, then finally, why would we want it in the factorized form? This is basically where these two x values, they tell us where the graph cuts the x-axis. Okay, so this is x1 and this is x2. So if you have the formula, the function in the standard form, and you want to find the x-intercepts, basically you're going to factorize it and then solve for it. You're going to equate it to 0 and solve for it, and that's where the x values come in. But we're also going to go into more detail with that when we actually plot graphs, or when you have to find, when the question says find the x-intercepts and so on. Okay, so that is your parabola, just the basics of the parabola. Then we have the hyperbola. So the basic hyperbola looks like this, and that's when it hasn't been moved left or right or up or down. Now the a value, what does the a value do? If the a value is positive, the hyperbola lies in the first and the third quadrants. Okay, and if the a value is negative, then the hyperbola lies in the second and in the fourth quadrants. Okay, so that is something you definitely need to remember when you sketch it. They can give you maybe -2 over x and you have to sketch it. Then you just need to know, okay, it's going to lie in these two quadrants. Now, the standard form that we know looks like this. And the p and the q values have the same purpose as they had with the parabola. The q value moves the graph up or down, okay, basically. So if the q is maybe -2, then the whole graph with its asymptote, that's important, with its asymptotes moves down, and then the p value also moves it left or right. Just be cautious about that sign over there. If it's going to the left, your equation, the equation for this graph will actually have a positive in the actual equation. So this could be maybe, let's say this is, where can we put it? Let's say we put it at 2 and -3. This is the, -2 and -3. So this is at -2, this is at -3. But the equation will actually look like this. It would look like y equals to whatever a value is, over x plus 2 -3. So this equation will be, the sign will be in the opposite than what it moved to left or right. All right. Then finally for the exponential. Now we've got 4 basic graphs, 4 basic forms, and this is very important for when you ask to sketch it. Now the very basic one just is an increasing function going from left to right, increasing. And we have our standard form f of x equals to a to the power of x. So this is a base, that's an exponent. Now before we do the next form, I just want to show you or remind you something of what happens when graphs reflect in the axes. Okay, so let's start with point. Let's say this point, which lies at 2, is reflected in the x-axis, in the y-axis. So that's the mirror. Then it reflects in the y-axis. So meaning it's going to the exact distance it was there. It's going in this distance, and then it becomes -2. So to sum it up, if you reflect in the y-axis, then the x changes sign. Okay, and similarly, if you're going to reflect a point in the x-axis, then the y changes sign. So let's say, well, we don't really have to, but you can see what happens. If it was positive y there, it's going to be a negative y there, and the x value stays the same. So what happens if I reflect this thing in the y-axis? It's going to be a reflection and look like this, where it reflects in the y-axis, but my x value is going to change to a negative. Okay, now another way we can write this is we can also write it as f of x equals to 1 over a to the power of x. And basically we just change that using exponential laws, where if we have, for example, x to the power of -1, we can change that to a positive. We can change the exponent to a positive by taking the base down. So we can write it as 1 over x to the power of 1. Okay, that is exponential rules. Hopefully you understand that. But that's the two forms that it can come in. Okay, now just to tell you also, we saw this one goes to negative. Now the a value in itself can never be negative. Okay, so the a value is greater than or equal to 0. Okay, and in the next slide we'll look at what effect does the a value actually have on the graph. But next we want to look at what happens if the graph is now reflected in the x-axis. Okay, it's going to look like this. So it reflects in the x-axis, but I want us to see what happened to get it to this form. Okay, so if I, for example, have the main one, we've got y equals to a to the power of x, then we reflect it in the x-axis. So what happens? The y changes to negative. So instead of having a positive y, we're now going to have a negative y. Similarly, we had a positive x here. Now we just changed it to a negative x. So this is going to be minus y equals to a to the power of x. Now, when we write a function, we don't want the function to be like in terms of negative y. We want the function to be in terms of y. So to get rid of that y, I'm going to write it as y equals to negative ax. But remember what I said about the a can never be negative, okay? So it looks like the a is negative, but it's actually, the negative is actually just a coefficient of the a, okay? If the a was negative, it would have been included in brackets to the power of x, because everything, this entire number must be to the power of x. So what is that negative? That negative is, if we remember, the standard form was f of x equals to b times by a to the power of x minus p plus q. That negative there is the b value. So in this case, it's the b value is -1. Okay, so this is then, if you see an equation is given to you in the exam, and you need to sketch it, and you see, okay, there's a negative in front of this term, then you know the shape is going to be decreasing in this way. Okay, and if you're given like an equation and it's maybe 2 to the power of negative x, you know that the shape is going this way, or if both is positive, it's just going that way. Then for the final one, we've got one that is reflected both in the x-axis and in the y-axis. So it's basically going to look like this, where you have both a negative x and a negative in front of the term. And once again, we can also write it in another shape like this, where instead of saying to the power of negative x, we can make that exponent positive and write it as -1 over a to the power of x. Then it looks like this. Okay, so this is then the basic equations and shapes, how they can be given to sketch them. here we're going to look at what A does. Now, this is not something really important that you need to know, but if A is 0, it forms a straight line, and the bigger A gets, the more steep it gets. So it just gives you a bit more insight. Sometimes when you have to sketch these graphs, they ask for a landmark point, just to like give an indication of how steep the graph is. And basically, to get a landmark point, you don't even really need to know this too much. All you need to do is you pick any point, you pick any x value, maybe 2, and then you substitute in 2 for x, and then you simplify and find the y value, and then that's your landmark point, just to give a bit more information on the graph. But we'll look at that more when we look at sketching graphs. And then the p-value, we saw left and right. So once the p-value is negative, it actually moves to the right. When the p-value is positive, well, in the graph, that is, okay? So if the p-value is positive, it goes to the right, negative goes to the left. But remember also here, if you have a function x plus p, it actually moves to the left, and same if you have a function x minus p, it actually moves to the right. Okay, just in terms of the function there. Now the final thing, moving it up and down, and notice how the asymptote moves together with the function. Okay, and this is quite simple. If the q value is negative, it's below the x-axis. If the q value is positive, it goes above the x-axis. Okay, so that was our 4 main graphs and just the basics on them.